Dear students, in this video we will deal with the properties of glucose. Now the properties of glucose are again categorized under two headings, that is reactions characteristic of open chain structure and of cyclic structure. So firstly we will deal with the reactions of open chain structure, in which the first reaction is oxidation. Glucose on oxidation with a mild oxidizing agent like bromine water is oxidized to a monocarboxylic acid, that is D-gluconic acid, in which the bromine water red color disappears and it acts as a test for glucose. On oxidation with a strong oxidizing agent like concentrated nitric acid, it gives a dicarboxylic acid, that is D-saccharic acid. Second reaction is reducing action. Glucose reduces both Tollens reagent and Fehling solution. Tollens reagent is reduced to silver mirror, as you can see in the reaction here, and Fehling solution is reduced to the red precipitate of cuprous oxide. Reduction. On treatment with sodium amalgam and water, glucose gives D-sorbitol, and on drastic reduction with HI and red phosphorus, on boiling it with HI and red phosphorus, it gives N-hexane. On addition of hydrogen cyanide molecule, it gives a mixture of two epimeric cyanohydrins, that is D-gluconitrile and D-mannonitrile, due to the introduction of new asymmetric carbon atom. This is the new asymmetric carbon atom. You can see here it is combined to four different groups. Next is reaction with hydroxylamine. With hydroxylamine, it reacts to give D-glucose oxim and removal of a water molecule takes place. Reaction with a semicarbazide. On reaction with semicarbazide, it gives D-glucose semicarbazone. Again, a water molecule is removed in the reaction as shown here. Next reaction is ozazone formation. In this, on reaction with hydroxylamine, on reaction with phenylhydrazine, it forms a hydrazone called as D-glucose phenylhydrazone, as you can see here. And if the phenylhydrazine is in axis, then three molecules, first molecule, here second molecule and third molecule, they react stepwise with glucose to give you D-glucosazone. On reaction with PCl5, it give a pentachloro derivative, that is pentachloroglucose. Here the chlorine molecule has been introduced in the reaction instead of H. With metal hydroxides like calcium, barium, strontium hydroxides, as a reaction is given with calcium hydroxide, that is slag lime, it will give calcium D-glucosate along with the elimination of water molecule as shown here. When it is treated with 12% HCl and heated, a dehydration reaction takes place, and it will give you it will give you 5-hydroxyl methyl furfural, which on further reaction with HCl give you levulinic acid, formic acid, and a resinous product. Next is reaction with alkalis. On reaction with strong alkalis, it gives brown resinous product, and on reaction with dilute caustic alkalis, that is NaOH or KOH, it gives a mixture of, it undergoes a rearrangement reaction and it gives a mixture of D-mannose and D-fructose reaction. A mixture of D-mannose, D-fructose and D-glucose. It is a sort of rearrangement reaction which has been given a name, that is Lobride-Bruun-Van Eykenstein rearrangement. Next is fermentation reaction. D-glucose in presence of enzyme zymase gives you ethanol and carbon dioxide. The second class of reactions is that is characteristic of cyclic structure. In this, the first is reaction with alcohol, that is formation of glucosides. As you all know that glucose is a mixture of alpha D glucose and beta D glucose. So alpha D glucose on reaction with alcohol results in the removal in presence of HCl, results in removal of our water molecule. As you can see here, this OH and this H is been removed together as a water molecule, and it will give you methyl alpha D glucoside. The methyl group has been attached here. This OCH3 is attached on the first carbon atom. It will give methyl alpha D glucoside. And similarly with beta D glucose, again the same thing will happen, and the water molecule will be removed. Now OH will be taken from the other side, and this water molecule will be removed, and will give you methyl beta D glucoside. So a mixture of methyl alpha D and methyl beta D glucoside will be formed on reaction with alcohol. Next is on reaction with acetic anhydride, also called as acetylation. In this also it reacts with acetic anhydride to with pyridine solution at 273 Kelvin to form a mixture of two anomeric pentaacetates. Now here you can see alpha D glucose reaction with 5 acetic anhydride molecules will give you 5 acetic acid molecules, and alpha D glucose pentaacetate has been given. Again you can see the rearrangement reaction. Acetate groups have been attached to all the hydroxyl groups. H has been replaced by the acetate groups, and 1, 2, 3, 4 and 5 acetate molecule. Pentaacetate has been formed. This is alpha D glucose pentaacetate, and this is beta D glucose pentaacetate. Only the difference is in the arrangement of H and OH group at C1 carbon atom, and rest is same. So alpha D glucose will give you alpha D glucose pentaacetate, and beta D glucose will give you beta D glucose pentaacetate.